Good. All right, now. If you understand this problem, you're doing very well. You are? Okay. Let me demonstrate the problem. Okay? Here I have my demonstrating device. Okay? You see the box? Okay. If I push this, right? It's going to stop, right? So, if I knew how fast it was going, why did it stop? What stopped it? Friction stopped it, right?
Yes.
Correct? Friction stopped it. So, if I'm in a car driving and I'm going at a constant velocity and then I hit my brakes and it takes me 50 meters to stop, you know, I was going 90K, let's say I was going 90K, 90 kilometers per hour, and I hit my brakes, and my final velocity is 0, and it took me 100 meters to stop. There's an equation right here which I can apply that will tell me what my deceleration was. Not my acceleration, my deceleration. My negative acceleration. Why am I saying this? Let me read the problem. It says, a crate is carried in a pickup truck, traveling horizontally at 15 meters per second. The truck applies the brakes for a distance of 28.7 meters while stopping with uniform acceleration. Negative, but uniform. What is the coefficient of static friction between the crates in the back, which is not sliding, didn't slide, and the truck bed, if the crate does not slide? Let me read that again. A crate is carried by a pickup truck that's traveling horizontally at 15 meters per second, constant. It applies brakes. The truck applies the brakes for a distance of 28.7 meters. Right? While stopping with uniform acceleration. What is the coefficient of static friction between the crate and the truck bed if the crate does not slide? Okay. So right away, let's just put in some numbers and calculate the acceleration. Is that okay? All right, so this is 0. This is 15 plus 2. There's A, and 28.7. Okay? Yes? So what's 15 squared? Anybody? What's 15 times 15? What is it? 225. Okay. So this is going to be negative. Let's change colors. Negative 225 equals 2A 28.7. Okay? So now, let's divide this by 2 times 28.7. Right? Equals A. Right? So what I did was I'm dividing this, right? Right? You get that? Let me redo that. So that's A equals 225 divided by 2 times 28.7. What do you got? What's A? This is what, 57.4? What do you got? Let me see. You got, no, that's not correct, because look what you did. You need parentheses, big guy. Show them how to do that. You need parentheses. Yeah.
That's what he did, actually.
No, he didn't. He didn't do it correctly. He ended up, he did 225 divided by 2 times 28.7. He, you didn't do it correctly. I'm being honest with you. You got it?
4.3.
No.
4.3.
Well, that's 25.7.
28.
3.9 here, right? Yeah. So, A, 3.91, correct? Yes or no? Thank you. So, can I erase all this? We don't need any of this. Okay? We get rid of this. We get rid of all this. Okay? We get rid of it all. We don't have the mass of the crate, the mass of the truck. We have nothing. But well, I'll tell you what we do have. We have the physics concepts. Correct? Yes or no? Right? Now, what was the friction equal to? In other words, what was the net force? What was the net force that stopped that truck? Wasn't it? No, don't do that because you're going to shake the camera. What was the net force that stopped that truck? That's huge. What was it? What's the net force? Look, guys, here's the truck. What's the net force? What's the outside force that's stopping that truck? It's called what? It's the friction, right? Yes? Isn't it the friction? So the net force equals the friction, doesn't it? Yes? So the friction is going to equal the net force, correct? Friction equals net force. Okay, now. Here we have a cup, okay? Now, I'm going to move this cup, just move it, you ready? Right? So I had to push it just enough for it to move, correct? Okay, now, we're looking at just before, just enough. So just before it moves, how much am I pressing it? How much am I pushing it? How much am I pushing it? I'm pushing it, what? How much am I pushing it? I'm pushing it, if it's just gonna move, the amount I'm pushing it is the friction, correct?
Yes.
So if it's but if it's not moving, what's the force going that way? It's the friction, right? So in other words, the friction going this way is the same as the applied force. So I'm applying a force which is equal to the friction, correct? And what's that called?
The net force.
Well, no, the friction is the net force, right? But I know that the friction is going to be the net force. We know that. But this is key. Remember this? Correct?
Yes.
So this net force, I get rid of this. So this net force is going to be equal to that, correct? Right? Isn't that true?
Yes.
Is that true? You understand that, right? Now you get it?
Yeah, I know.
So if my net force, which is the friction, so pushing this, that's the external force, the friction, right? Right? I know that that's going to be the same as mu Fn, same, correct? Now, it's a horizontal surface. So what does Fn equal? Fw, right? So now I can say, I'm going to erase all this. I'm going to erase that. I can say, okay, so this mu Fw equals Fnet, correct? Well, what does Fnet equal? Remember? Chapter 6? It equals MA, doesn't it?
Yes.
Yes?
Yes. It's a good lesson.
All right. So, I can change this to this, correct? And isn't this mu mg? Isn't mg the weight?
Yes.
Isn't it?
Yes.
And I know that Fnet is ma, correct? Yes or no?
Yes.
So, these cancel. And what are you left with?
The acceleration.
You're left with, no, you're left with a little more than that. You're left with mu g equals a. Remember, let's go back to the problem. Maybe we need to reread the problem. It says, a crate is being carried in a pickup truck traveling at 15 meters per second. The truck applies the brakes for a distance of 28.7 meters while stopping with uniform acceleration. What is the coefficient of static friction between the crate and the truck bed if the crate does not slide? So what we're doing is we're calculating mu, aren't we? So now we know that mu equals A over G. Here's A. If you want to get technical, G equals 9.81 meters per second squared. So U equals 3.91 meters per second squared divided by 9.81 meters per second squared, which equals what? What does 3.91 divided by 9.81? What do we got? What's, I need, oh, 0.398, 0.399. 0.4. 0.4? 0.4. All right, so mu equals 0.400. And what are the unit labels for coefficient of friction? This is static friction? None. That's it. Understood?